Imagine you are providing web services to your customers, where ensuring full availability is your highest priority. To protect your environment from DDoS attacks, you invest a significant amount of money in a bot defense solution. However, a hacker discovers a vulnerability that allows them to take the entire application offline by sending legitimate-looking requests that easily bypass both the web application firewall and the bot defense systems. This attack exploits a vulnerability known as web cache poisoning. In the following, we will demonstrate how to carry out this attack. Let's briefly discuss web cache poisoning and then explain how it can be used to facilitate denial-of-service attacks. To reduce traffic loads on backend services, web applications commonly use cache servers. The cache, which acts as an intermediary between the user and the application servers, stores or caches responses to specific requests for a fixed duration. When another user sends an equivalent request, instead of sending the request to the backend servers, the cache server sends a copy of the response to the user. Upon receiving an HTTP request, the cache server first checks whether the same request has been cached to send back the copied response. This request checking and comparison is not done with every HTTP header, but mainly the GET parameter and the host header, because these are the main parameters that determine the response. The rest of the headers could be different, but the response would be the same. For example, with any machine and browser that the request is sent, the response would be the same, and thus user agent does not need to be cached. Now, imagine a scenario where a user sends a request with the correct GET and host header value for the application, but also includes additional header information that triggers an error message as a response. If the user can persistently send this request and cause it to be cached, they effectively exploit the cache to store the error response. This can take the application offline, because once the error response is cached, any other user requesting the same page will receive the cached error response instead of the correct content. For example, consider the following request that includes if modified since XXX. If the backend server receives this request, it may respond with an error page, particularly a 400 or 502 bad request, because the value of the if modified since header is invalid. If this request is sent repeatedly and gets cached, subsequent users accessing the same page will receive the error response, effectively denying access to the application. Interested readers can refer to the following document, which provides a detailed explanation of how to mitigate the risk of web cache poisoning. Specifically, for handling these malformed header values, the risk can be addressed by configuring the cache server to avoid storing error responses in the cache. Hope you enjoyed this video and learned how to improve the security of your web environment.